We present the method for improving fairness in facial albedo estimation via visual-textual cues. Recent 3D face reconstruction methods have made significant advances in geometry prediction, yet further cosmetic improvements are limited by lagged albedo because inferring albedo from appearance is an ill-posed problem. To this end, we reconsider the relationship between albedo and face attributes and propose an ID2 albedo to directly estimate albedo without constraining illumination. Our key insight is that intrinsic semantic attributes such as race, skin color, and age can be used to constrain the albedo map. We introduce visual-textual cues to supervise facial albedo estimation and train an end-to-end mapping network to infer albedo maps from ID feature. Our ID2 albedo outperforms state-of-the-art albedo estimation methods in terms of accuracy and fidelity. 3D face reconstruction is one of the fundamental problems in computer vision and graphics. It aims to estimate realistic 3D face shapes and appearances from 2D images, given only multi-view or single-view images. 3D face reconstruction plays a vital role in numerous vision applications, such as face manipulation, speech-driven facial animation, and video conferencing. To enable more realistic applications such as avatar creation, interactive AR and VR, fine-grained albedo reconstruction attracts a lot of attention. Unfortunately, inferring albedo from pixels is an ill-posed problem. Assuming that the face is a Lambertian surface, the rendered face image R can be computed by a multiply S where R stands for the final rendered image, A and S represent the wrapped face albedo and the shading image, respectively. When there is a parallel estimation of both albedo and illumination, the ambiguity between albedo and illumination happens. For example, an African face image can be decomposed into both dark skin and bright illumination or light skin and dim illumination. Existing methods attempt to achieve approximate results. The primary approaches are creating a texture model to restrict the albedo space and introducing additional lighting constraints to reduce ambiguity. The main reasons behind the biased albedo estimation include biased albedo models and limited lighting constraints. Despite these constraints, most current albedo reconstruction methods continue to bias light-colored albedos, unfair to people of different ages and races. To address the above issues, recent work rebuilt a balanced albedo model, estimated the environment light from the scene and used this prior to decrease the ambiguity between light and albedo. Given the difficulty of the illumination estimation for both face and scene, the albedo estimation method proposed in Trust is still vulnerable under complex scenarios and complicated facial appearance variations. It is natural to ask the question, how can human beings disentangle light from a single image? There is no doubt that the answer is prior. Given the fact that facial albedo is related to facial attributes, e.g. ethnicity, age, and skin color, we consider exploring attribute constraints during albedo estimation. For example, African albedos are primarily dark, while Caucasian albedos are mostly light. However, race alone is insufficient because the albedo of different individuals within a race varies due to age, skin color, and other factors. Therefore, we attempt to use diverse facial attribute priors to constrain the albedo estimation. We choose to build an unbiased albedo generator and then use facial attribute priors to constrain how the generated albedo will appear. It is important to note that we do not apply any constraints to the lighting model. Given a facial input image, we first infer facial geometry by an off-the-shelf face model and extract the identity feature by a pre-trained arc face model. We then map the facial identity features to our pre-trained albedo generator latent space to achieve high-quality albedo maps. Combining the face shape, albedo maps are wrapped to image space and rendered using the predicted illumination coefficients. Besides, we predefine several facial attribute cues and label each input image by clip visual-textual similarity. Finally, our rendered images are supervised by various text-based facial attributes and image-level losses in an end-to-end differentiable way. We train a high-resolution albedo generator as the current PCA-based albedo model fails in reconstructing high-frequency facial details. Given 100-level training data, high-resolution GANs are not easy to train. To this end, We replace the single large discriminator with 4 smaller discriminators, which are applied to the feature pyramids produced by a fixed ImageNet model. For the evaluation part, we follow trust and use individual typology angle, simplified as IDA, score recommended to classify skin tones into 6 categories, where L and B represent the lightness and yellow-blue components of the C-Lab color space. Following trust, we perform a qualitative and quantitative evaluation on the FAIR benchmark. Our algorithm obtains the best results in IDA average score and very dark skin types, and is almost equal to trust in the overall score. In contrast, the rest of the algorithms are biased toward different skin types. Our method has a slightly higher error in type 1 and type 5 skin for different skin types since training data hardly includes the white skin tones. The network prefers to interpret the very light albedo as white skin tones in type 2 due to the uneven distribution of skin tones in training data. The same is true for type 5 light black skin. Trust achieves a minimal bias score because of semi-supervised learning. Overall, our algorithm makes good progress in IDA and achieves state-of-the-art. Visually, a common problem with current methods is a strong bias towards specific skin types or albedo models that limit the modeling of appropriate skin tone types. Both trust and our method perform albedo estimation very well. Thanks to a powerful albedo generator, our method produces more realistic results. To evaluate our approach's robustness in real-world images, we qualitatively compare it with other methods on the FFHQ dataset. The results show that our albedo achieves more realistic results while maintaining fairness. We also conducted ablation studies on our full pipeline, which demonstrated the effectiveness of our modules. Here are more visualization results. Thanks for your watching.